Simplifying rational expressions. A rational expression, there's the word ratio, that's just a fraction. So all the methods you know for simplifying fractions are going to work to simplify rational expressions. Let's take some examples. When we add fractions, we talk about getting common denominators. So I really want a 7 here and a 5 there. So we're going to find a common denominator. So I'm multiplying by 7 over 7 and 5 over 5. Now, why do we do that? I know I want a 7 here and a 5 there, but why 7 over 7 and why 5 over 5? Well, what is 7 over 7? That's just 1. What is 5 over 5? That's just 1. And when you multiply by 1, you don't change anything. So we're keeping the expression the same. It will just look different. All right, what does that do for us? We'll have 14 on the top, 20 on the top, 35 on the bottom. And once we have that common denominator, we can add the 14 and 20 and get 34 over 35. Let's do the exact same thing here. Our denominators, we want x plus 4 and x plus 1. So we'll multiply by x plus 1 over x plus 1 over here, and x plus 4 over x plus 4. Again, all you've multiplied by is 1. So nothing has changed, it just looks different. All right, so there's our multiplication, and then we'll multiply the 3 by the x plus 4. We didn't have to do that here because we were multiplying by 1. That will give us 3x and 12. And now that we have our common denominator, we can look to add like terms. 4x and 13. And then get in the habit of stating all your restrictions. That will be really important when we multiply and divide. But it's good to get in the habit now. So anytime we have a rational expression in the denominator that could be 0, we have to say what x is not allowed to equal. So what would make x plus 1 equal 0? Negative 1 would. What would make x plus 4 equal 0? Negative 4. So what did we do again? We found a common denominator. And when you multiply x plus 4 by x plus 1, make sure you do it to top and bottom so that you're really multiplying by 1. Once you have your common denominator, collect your like terms. Let's look at multiplication. What you do with fractions when you multiply is you multiply the numerators together and you multiply the denominators together. We did that on the other page. All right, so 1 times 2 times 3 times 4, and then the bottom 2 times 3 times 4 times 5. That gives us 24 over 120. Wonder if we can reduce. 24 goes into 24 once and into 120 5 times. So our answer is going to be 1 over 5. And what you want to ask yourself, is there a smarter way to do this? We multiplied and then we reduced. What if we swap the order? What if we reduce first? So here when we got from 24 over 120 to 1 over 5, we said, was there anything in the top and anything in the bottom that we can divide? So I could divide 2 into those, because 1's in the top and 1's in the bottom. 3 into those. 4. And that would leave us 1 times 1 times 1 times 1, and 1 times 1 times 1 times 1 times 5, which is going to give us the same answer. And it's much better because the numbers were smaller. So you're allowed to do that. As long as things are all multiplied together, you can reduce anything at the top with anything in the bottom. So instead of multiplying and reducing, we're going to reduce and then multiply. Okay. Ooh, well, doesn't this look different? So this is really different because things aren't multiplied together. But what if we factored? If we factored, then everything's multiplied together. Ooh, genius idea. All right, what could we do here? 2 terms and a minus sign, that looks like difference of squares to me. So 4x squared is 2x and 2x. 25 would be plus 5 and minus 5. And what about this one? That's 3 terms, looks like trinomial factoring. Multiplying to 2x squared, I'd have a 2x and a 1x. 20, I'm going to try 4 and 5. I wonder if that'll work for us. 5x and 8x. Yeah, that gives us 13 if they're both negative. Oh, and this has a common factor. Let's pull a common factor out and we get 2x plus 5 when we're done. Okay, what does that do for us? Anything common to top and bottom? Reduce those and get 1. Reduce those and get 1. reduce that and get 1. Oh, this is amazing. So our final answer, 1/2. And here it's crucial that you write down all your restrictions, because when you have lines in math, this line has to equal this line has to equal this line. And this line has all sorts of restrictions. It's easier to see them here. X cannot equal 5/2, 4, or -5/2. Oops. And so you must state your restrictions. Otherwise, we end up with something that's not true. Really, we should have stated the restrictions here, because this line is not actually equal to all the other ones. So what can X not equal? Can't equal 5/2, can't equal 4, and it can't equal -5/2. All right, so quick recap, what did we do? We factored everything. We needed to factor so that things are now multiplied together. And then we reduced anything that was the same. State your restrictions so that the lines are really the same as each other. And simplify as much as possible. Let's try dividing. What does 5/4 divided by 15/6 mean? Oh, it means this. And if we were to multiply to get 1 in the denominator, we'd have a much nicer fraction. So if I wanted a 1 in the denominator, I'd need to get rid of a 6 and get rid of the 15, because then those would reduce. Now, if I do it to the top, I have to do it to the bottom. Okay, so this is what we're doing. It's known as multiplying by the reciprocal. So the reciprocal is just this function turned upside down. And why are you allowed to do that? What is 6/15 divided by 6/15? It's just 1. So again, because all we've done is multiply by 1, we're allowed to do this. Okay, what does that do for us? We can reduce these. 5 goes in there once and 3 times. 2 goes in here twice and 3 times. And we know these just become 1 and 1. Oh, and then this looks like this will reduce. So what's our answer? We get a half. Ooh, that was lovely. And as always, is there a smarter way to do this? We told ourselves that we're multiplying by the reciprocal. We know we're just getting 1 in the denominator. So what if we just did that? Well, that's quicker. So instead of saying dividing by 15/6, we say we're going to multiply by the reciprocal. So we multiply by 6/15. Is it really that simple? Give us 1/3, 2/3. Those 3s/3s are going to reduce, and we get 1/2. It is that simple. So when you're dividing by a fraction, you're simply going to multiply by the reciprocal. Why did we just look at the top? Because we know we get 1 in the denominator, and then we just skip that step. Okay, how does this work? We're going to factor first. So we did trinomial factoring and pulled out a common factor. We're dividing by this. Let's multiply by the reciprocal. So we just turned it upside down. Now we look to see if there's anything we can reduce. Anything multiplied on top and bottom that's the same can be reduced. Okay, so there's our 3x/x + 3, and state all restrictions. Now again, if there were any restrictions at the beginning, we have to state them. And not only that, you've got to be super careful. If anything spent any time in a denominator, it cannot equal 0. So be careful, because you might say x cannot equal 1, -3 or 2, but make sure you look at when it's divided as well, because x can't equal 0. And truth be known, we should really be stating it here as well, so that all the lines are mathematically equivalent. Okay, quick review. What did we do? We factored. When we're dividing, it's the same as multiplying by the reciprocal. The reciprocal is really just this turns upside down. Simplified, stated all restrictions from any term that spent any time on the denominator. All right, go have some fun.